Hi there guys, Adrian O'Sullivan here. Just doing another tutorial on limits. This is the second example. It's a tiny bit more difficult than the first example I did, and I'll just put a link to the first example. So this is just an example of x squared minus 3x minus 4 over 3, or x cubed minus 2 x squared minus 5x minus 12. So if we fill in x is equal to 4, x is equal to 4 directly into this equation, you'll find that it will be equal to 0 over 0. And that's not allowed, so we have to break it down into and find its roots by separating it. So dealing with the numerator first, we have x squared minus 3x minus 4. So when we break that down, we multiply 1 by 4. So we find the common product. So it's 1 by 4, 2 by 2, and they're all equal to 4. We take the polarity in the first, or in the middle section, and at that, having it as minus 4 and minus 2. And if the outer two signs have different signs, then these are going to be different. So it's going to be a plus instead of a negative. And you can see that this value is plus, or 1 minus 4 is equal to minus 3, so that's why we picked that one. And that's why they are the roots. So then moving on to the denominator, we get x cubed minus x squared minus 5x minus 12. And let's assume for now that one of the roots is either x equal to plus 1 or minus 4. So, or minus 1 and plus 4, sorry. Because one of the two roots on the numerator is minus 1 and plus 4, so the question is probably going to cancel out one of those values. So let's just take x as minus 1 first, and then divide that to get the product of it. So that's minus x squared. We get minus 3x squared minus 5x. Just doing normal division. I'm running out of space here, so I'll bring it up. This should be plus 12, but it's not. I got a remainder of minus 10. So what's that all about? Huh? So it's obvious here that with a remainder, it's obvious that it must be it must not be a root. So it must be that x plus 1 is the root, or x is equal to minus 4. So when we do the long division then of this, just the same process again, we get x squared plus 2x squared minus 5x squared. That's 3x. Bring down to minus 12. This is going to be plus 3. 3x plus 12, and that's 0. So there's no remainder, so that's perfect. So, woo! Fireworks. Celebrations. Getting a bit distracted here now. Yeah. Anyway. So filling that into the denominator, we get x minus 4 by x squared plus 2x plus 3. So when we fill the numerator and denominator back in, and this is the original form that it was in, and then you fill in for the limits of the numerator and the denominator. And we can see here that x minus 4 is going to get cancelled out on the numerator and denominator. So then we're left with the limit of x going to 4 with x plus 1 over the top and x squared plus 2x plus 3 on the bottom. So then when we fill in for x equal to 4, we get 5 over 27. So that's the value. So when we fill this equation in to the original equation into Wolfram Alpha, it's just a website online. It's a fairly good one where you can just put in a formula and it'll analyze it. It'll differentiate the function, integrate it, find its limits, find its exponential, a summation kind of format. It's Taylor series and all this. So let's just see what it looks like. So you can see that the equation here, you also have to check the equation at the top and see if it's right. And you can see the first graph is when those x minus 4s are cancelled out. And you can see that when we have x is equal to 4, the y value is equal to 5 over 27. So we know it's right. So thanks for watching. I hope it made a difference, and have another look at my other videos on L'Hopital's rule. So thanks for watching. Leave a few comments. Thanks.